Alrighty. Hello, everyone, and welcome. I'm Will Wade. I'm one of the core contributors to the Frequency blockchain, and today I'm going to make a case to you for the use of smarter, more case-specific sidecars for blockchain. Now, before we get into the details there, I want to talk a little bit about sidecars. What are they? All right, there's a couple basic points. Sidecars, for the most part, are standardized pieces of code. They're API servers that you can deploy. They're usually gateways to other servers. There's other code that's actually doing some of the work. It's doing kind of a translation layer. And it's usually run by the consumer of that API. Now, that's not always true. You can see that little asterisk, and we'll talk about that a little bit later. But the key here is why. Like, why do we care about sidecars for blockchain in particular, and why might we actually use one? So this is kind of a story about complexity. So in the case of frequency is one of the core use cases is decentralized social media. And decentralized social media is complex. There's a ton of data working through the systems. There's a ton of pieces and parts. Here's a few pieces of it, right? There's a decentralized identity piece. There are network operations. There's public keys, encryption keys that have to be managed, that have to be handled. There's the actual social graph itself, the encrypted social graph in the case of frequency, and how that's managed on chain. And then there's the content itself that's flowing through, or references to references of content as you might have need. And so as we were working through all of these details, we were having a lot of trouble with different people integrating. And we came back to that classic age-old software engineering tool, which is, instead of building social media infrastructure for users directly, let's build infrastructure for applications. And so this looks a little bit like this. In the case of frequency, we have users, they use applications. Those applications talk to the blockchain. In this way, we've kind of protected users and isolated that complexity away from them. There's still ways to ensure self-sovereignty through direct no-fee delegation revocation, but a delegation system, this allowed us to say, okay, instead of users having to worry about all the complexity of the blockchain and such, we're going to push that complexity over to the applications. Applications that are probably run by people who have software engineers and people who can interact with that complexity. But as always goes, we had a lot of other problems to solve, right? So how do we get these applications onboarded quickly? Some of them are legacy Web 2 applications. That means they're running Scala, they're running all kinds of different languages that might not be as common in the Web 3 ecosystem. There's a lot of complexity in Web 3, right, that a Web 2 developer might not be used to, right? If you're trying to integrate an application, you're going to end up with, wait, you say I just send this off and I don't get a response back yet? How do I find out my return value, right? Classic problems as people get into the Web 3 ecosystem. There's also data access, right? Where is the data coming from besides the blockchain? Do I need to worry about CCIP or IPFS or any of the other decentralized file systems? How do I get all that together? How do I verify that it's true? There's queuing involved, right? If I'm going to send batches of information off to the blockchain, I might need that problem. I might need a secure key space. If I'm an application that's pushing things to the blockchain, actually interacting with paying fees and such, I need to have a secure place to keep that key and to have those interactions. So many more problems. And this brings us back to the classic, right? Complexity, you can't always get rid of complexity, but you can choose where you put that complexity. So as we work through the kind of classic problems, right? So here's classic Web 3, right? You have blockchain, you have clients. Nice and simple. And here, complexity obviously has a cost on the blockchain side. It costs money to do things on the blockchain. And so we try to do as little on the blockchain as we can, and that forces every tiny little piece of complexity over onto the client side. Uh-oh. Now we've got a lot of code, we've got a lot of bloat on these clients. People, oh, I want to build on top of my blockchain protocol. What do? Well, you bring in that nice, cool SDK, and it handles all that complexity for you. Or you try to do that. And we definitely went through this as we were working on the social media interactions. How much can we put into an SDK? How much can it do? And of that original list, right, it did help with our onboarding speed. It didn't help really, though, with legacy Web 2 applications, right? Primarily because of the language problem. We couldn't build 5 different languages all at the same time necessarily. It didn't hide much of the Web 3 complexity for those applications. It didn't help handling the interactions with IPFS or other decentralized decentralized systems of file storage. Queuing didn't happen, but we did have, this was very good, we had a nice secure key space, right? If the application is doing the SDK, they're kind of managing that key and making sure it's safe. So we got a couple wins here, but not all out. So let's go to a slightly more common, right? A lot of people use Infura or other providers, maybe Pinata for IPFS. And so you have this common infrastructure that you can connect up to. And let's see again, we'll apply again, once again, our fancy SDKs. But we haven't still solved so many of our problems, right? Our onboarding speed definitely increased. That's good. We've got a little bit easier Web 2 application integration. We've managed to get language independent with these third-party infrastructure pieces. We've got data access kind of figured out, but we still don't have queuing. Now we've lost our secure key space, right? It's on a third-party infrastructure server. That's a problem. So we were thinking, well, what if that infrastructure can be more interactive, can be smarter, more case-specific to our own use cases, right? What can we put kind of in that original diagram? What can we put in between those applications in the blockchain? And that is kind of where the sidecar pattern came to use for us. So here's an example application infrastructure that someone might build, obviously still simplified, but using frequency and the frequency social system, right? You've got your kind of all classic back-end pieces, right, that you need to do if you're trying to provide search over top of the systems of social media. If you're trying to provide user-specific details and streams, you may very well need to have a lot of back-end data that you're using, caching, to provide good experiences for your end users. But notice that this back-end no longer has to connect directly to the frequency or to IPFS. It doesn't need any of that access. Instead, we have this kind of sidecar slot that we can put in all of those pieces. And remember, we've got a lot of those pieces, and this kind of brings us to everything's green bliss, right? This has changed our ability to do onboarding. It's made it really easy for legacy Web 2 applications to really get up, because guess what legacy Web 2 applications speak? They speak API. They are really good at it. Doesn't matter what language they're using, they're really good at it. We've got our data access, we've got our ability to do queuing with Redis or other queues that can be added into the system, and all of this including a secure key space, because remember, it is not shared infrastructure, it's shared code. Right? All of this is still running inside of the application, the company who's running this application. It's running inside of their infrastructure. They're controlling that security model, but with the ability to also easily integrate. So this gives us all of this place to stuff all of that complexity that we have, right? Remember, we had a lot of complexity. We have that decentralized identity pieces that interact with it. We have those network interruptions like encryption keys and such. We have this encrypted social graph that also has to be compressed and paginated to get on chain. We have content management that gets batched and pushed out. All of that can get pushed into these little sidecars. In fact, we've split it out into multiple sidecars so that each one is as specific and independent as possible. So if you want to sit there and say, oh, well, I'm going to use the sidecar for the graph service. Graph works just like I want it to. That's great. Social graph, all good. But I want to do some crazy things with content, or I want to do something special there. You don't have to use the entire package. This is, again, a great piece of this kind of shared code that many different people can run. They can choose which parts of it they want to run. They could even fork it and modify it to run themselves. So, when do you think a sidecar, when do I think you might want to start thinking about a sidecar as a solution, right? Because SDK is a great solution. Infrastructure that's public infrastructure like IPFS and such, great solutions. When specifically might you want to use a sidecar? So one is services. So if your users aren't people, but they're computers, if you're actually doing infrastructure like this is doing for where the applications are saying, hey, we're going to take care of this, you don't have to worry about this complexity. If you're trying to talk to servers, sidecars might be a great solution for you, right? Servers are great at talking APIs. Last I checked, I didn't talk to humans in APIs. At least that seemed to be a more natural language interaction. But this can also apply if you're interacting with EIP 4337, the alt mempool, alternative ways to pay and such. This might also be a solution for you. So if you're trying to operate a bundler and you want a more specific bundler to your specific use cases, this might also be something to go look at. Another thing is if you're dealing with a lot of off-chain data, right? If you don't want the user to have to worry about validating data, going and fetching, I mean, do you really want your user to have to be interacting with IPFS? Now, I love IPFS. It's a great technology that they built and the other decentralized file storage systems, but it is not quick. It's not easy. It needs a cache in front of it. If you want to build a great user experience, you may not want your users directly interacting with that data. This also matters if you're dealing with data that might change over time, right? On the blockchain, we don't do too much of, I'm going to change the structure of data, but we might very well do that with off-chain data. However, with a nice API, we can hide a lot of that purely data structure changes and instead put that complexity all the way back into those sidecars. Finally, if you're trying to do Web 2 integrations, this, I think, is the biggest piece here that pushed us toward this solution because Web 2 applications, they already speak APIs. They don't talk most of the time in Web 3 timescales. They don't think in probabilistic. They don't think about finalization, nor should they have to think about many of those things if the integration doesn't require it. So, are you not convinced yet? I mean, I thought I made a pretty good case, but maybe you're not convinced. So let's take a look at something most people are pretty familiar with here, ENS, right? ENS is a relatively simple setup, and it's got a nice, wonderful set of SDKs already. So congratulations to the ENS crew and all of their contributors. That's a long list. And yet, it still doesn't capture all of the languages that are out there. So we've already ran into that problem of if you're trying to interact with someone who's in an ecosystem that's not listed here, you're already potentially in trouble and having to port an SDK just for that. It's also, just what are we trying to do with it? So let's look at the simple resolve. If you're trying to just simply resolve something, you need a connection to Ethereum. Now, that might not sound like a big deal, right? But if you're a server, you need to make sure, hey, is that connection to Ethereum still up? What about retries? Do I need to retry? Do I need a failover? All of those different interactions when you're working at the server level. Do you care about finalization? Do you care if your ENS lookups are finalized or not? Maybe you do. Off-chain resolutions, right? ENS has wonderfully expanded out to L2s and using CCIP. Do you need to be able to connect to those? Do you want that details in your application, or do you want it in kind of a shared code base that you can use? There's also reverse lookup. Do you want to be able to verify the canonical address? Is this the canonical address? Is it not? Do you want caching? Do you want an interface that matches DNS and actually serving this up over port 53? Hopefully you're using HTTPS DNS, but All of those pieces lead to a large set of complex questions for something that is, at the end of the day, a 2-parameter read-only function, right? We didn't even get into the details of putting in a new ENS entry and making sure it's up to date and managing the resolvers and all of those pieces. And this is a great SDK. I'm not saying we should make a sidecar for ENS, but this is a great little example of how a sidecar can help answer a lot of these questions and make your infrastructure a lot easier. Okay, there's also a secondary benefit, and this is actually one of my favorites, which is you get great API documentation. API documentation has evolved over the years, but now with Swagger and OpenAPI, there is great UIs. You have a nice standardized way that almost any engineer can look at this left-hand side and parse it and understand what's going on. And then plenty of great UIs to interact with this. This is a system that, while not necessary, right? There's plenty of great API and great documentation for smart contracts and such. This gives you a much more feature-rich, right? This is specific. This is versioned, right? So you can talk about, hey, hit this version of the API. It's going to do something different. Oh, the underlying protocol's changing. We need to deprecate something. We need to throw an error. We need to return something. All of those become much more possible when you start interacting with API documentation that is actually both interactive and has things like mock servers and other things can easily be built out of it. So the final thought here, right, is at the end of the day, it's a question of where do you want to put your complexity? Your code, your protocol that you're interacting with, your blockchain, all of it has complexity, and your choice is kind of where do I put that? And there's a lot of different pieces, right, that go into that. Where is the cost? How easy is it for users? What are my users look like? Are they humans? Are they computers? How is that going to interact? And so all of those choices kind of come into play, and I want to make sure sidecars are kind of one of the things that come to your mind as you're thinking about, well, what's another place I could put this complexity? It hasn't worked to put it in an SDK. It hasn't worked to put it in shared infrastructure. And these kind of sidecars give you that option to do that. So again, I'm one of the contributors to Frequency. You can learn more about Frequency at frequency.xyz and read about kind of the sidecars and how they actually work. We have documentation and such you can read on there and kind of see how it works. If you're interested in socials particularly, I suggest go look at and decentralized social, go take a look, see how it's kind of implemented. And if you're just interested in the sidecar piece, go look at it and kind of see, oh, here's how they made decisions. Maybe we made the right decision, maybe not. You can feel free to please go to the GitHub and put some issues in, put some questions in, and I'll also be around later. With that, I'll see, do we have time for questions? Maybe one question. Anybody have one question? If not, I'll just stand up here for another 2 minutes and until this guy kicks me off. All right, there's one. Nope, not a question. I thought there was a question, but there's not. That's great. Hey, you can catch me afterwards. I'll be hanging around. Thank you again very much, and hope you enjoy the rest of the conference.